Hello everybody, welcome back to our video series on GCSE Maths Revision. Today we are going to investigate the cosine rule and look at question 26 from the paper. So what is the cosine rule? Well, it's kind of an extended version of the Pythagorean theorem. If we take some triangle which is not a right angle and not a right triangle, so for example this one would do, and we put some angle in here, theta. In fact, no, we'll call this angle little a, this angle little b, and this angle little c. And then this is very important. Opposite to these angles, we have their capital counterparts. So opposite from this angle, we have big A, and so on and so forth. The cosine rule tells us this. It tells us that a squared is equal to b squared plus c squared minus 2bc cos a. And equivalently, of course, that b squared is equal to a squared plus c squared minus 2ac cos little b, and lastly c squared is equal to a squared plus b squared minus 2ab cos little c. These are all, if you like, equivalent. You can use any one of these, it doesn't matter. So long as you keep the angles the same. You couldn't go and swap b in this case for a and so on. You have to keep them the same. For the time being, I won't prove the cosine rule because we don't need to worry about that at this level. But as always, if you would like me to prove it, please ask me, recommend it. As always, thank you very much for my continuing support, and do share this video with somebody who could benefit from it. Now, question 26 on the paper says this. It says that the area of the triangle, this triangle, is 25 root 3 centimeters squared. We are given an angle of 60 degrees. We have an unknown length of x centimeters, 20 centimeters here, and then another unknown length, w centimeters. It's just centimeters. Work out the value of w. Give your answer in the form a root b, where a and b are integers greater than 1. Now then, that's going to be a bit difficult, surely, because we have two unknowns. Well, not quite. We can calculate x. We have to use another formula for the area of a triangle. That the area is equal to 1/2 AB sine C. Now, thankfully, we know enough about the triangle to work out what x is. So if I start putting things in, 25 root 3, the area, which is written here, this is equal to 1/2 times 20 times x times sine of 60 degrees. Now, if we start multiplying things out, we have that 25 root 3 is equal to 1/2 times 20 is 10. 10 times x times sine of 60 is the square root of 3 over 2. These are sort of, there are rules to learn what, sine, cosine, etc. are, but for the time being, it suffices to just learn them. If you can detect the pattern, then that's great. But if you can't, then obviously don't worry about it. Just know that those are the important numbers. So again, 25, we can cancel the root 3's out because we're just multiplying. So 25 is equal to, and again we divide we can divide 10 by 2. 25 is equal to 5x. And then we get that x is equal to 5. Nice and straightforward. Nothing too complicated going on. So now we can redraw the triangle. We don't need to worry about the area. We are done with that now. 520W. Now we're ready to work W out using the cosine rule. This cosine rule specifically. We know that, nope, ignore me, this one. We know that c squared is equal to a squared plus b squared. As you can see, this is the Pythagorean component, minus 2ab cos c. So in this case, c is w. So we have w squared is equal to 20 squared plus 5 squared minus 2 times 20 times 5 times cos of 60 is 1/2. So w squared is equal to 400 plus 25 minus 100, which is equal to 325. And lastly, we have to take the square root. Now, we could leave it like this, but as you can see, the question specifically tells us that we have to leave it in the form of a root b, where a and b are integers greater than 1. So effectively, what this is saying is this is equal to 1 root 325. So 325 is greater than 1, which is okay, but sadly, 1 isn't greater than 1, so we can't leave it like this. So we need to start splitting this up. So let's think about, when we do surds, we know that we can rewrite surds like this. If we have the square root of a times b, this is equal to the square root of a times the square root of b. And of course, to make this easier for ourselves, what we should look at is if we can write 325 as a multiple of some squared number. So first of all, let's list off the squared numbers. We have 1, 4, 9, 16, 25, and so on. Well, we see that 325 is a multiple of 5. So 25 is looking like a good start. It's not going to be 1. It's not going to be 4 or 16 either, because 325 isn't even. Could it be 9? Well, there's an easy way to check. To find out if a number is divisible by 3 or 9, you add the digits. So 3 plus 2 plus 5 is equal to 10. And unfortunately, 10 does not divide 9, or 9 doesn't divide 10. 10 is not divisible by 9. And therefore, 325 is not divisible by 9. So, it could be 25. So what is 325 divided by 25? Well, we could pull it into our calculators, but this is a non-calculator paper and we're not given one. So we have to work it out. It's 13. Why? Because we can split this 325 up into 100 plus 100 plus 100 plus 25. And then when we divide all of this by 25, because we have addition on the top in the numerator, we can split these fractions up. 100 over 25 plus 100 over 25 plus 100 over 25 plus 25 over 25. This is 4 plus 4 plus 4 plus 1, and this gives us 13. So what do we do next? Well, the square root of 325 is equal to the square root of 13 times 25. And by this rule here, we can split this up into the square root of 25 times the square root of 13. This is, of course, 5 times the square root of 13, which we just write as 5 root 13. And this is our final answer, 5 root 13. It works because 5 and 13 are both greater than 1, and they're integers, they're whole numbers. Thank you very much for watching. Please share this video with somebody who could benefit from it. Also, don't hesitate to give me any feedback. Tell me what I did right, tell me what I did wrong. Thank you very much for watching.